Hello, my name is Riccardo Scandariato and welcome to the Advanced Software Architecture course. This video is part 3 of the lecture on quality requirements. In part 3 of this lecture, we focus on eliciting and representing quality requirements. A quality attribute scenario is a way to represent a quality requirement. A scenario is comprised of 6 parts. The source is some entity generating a stimulus. Such entity could be an end user, a third-party system, a sensor, and so on. The stimulus is a condition that needs to be considered when it arrives at the system. The artifact is the part of the system to which the requirement applies. For runtime qualities like performance, this might be the running system of a part of it. For development time qualities like maintainability, the artifact could be the design or the code. The environment is the circumstances in which a scenario takes place. For instance, a requirement might specify the system behavior in overload conditions. The response is the activity undertaken after the arrival of the stimulus. When the response occurs, it should be measurable in some fashion so that the requirement can be tested. Now that we know what a quality attribute scenario is, we still have the problem of how to create one. Of course, if you are an experienced architect, you will have extensive knowledge about the qualities, and you can use your own expertise to elicit the relevant quality attribute scenarios. If you're starting out as an architect, you are not out of luck though. In the course book, there are a number of tables you can use to systematically elicit the quality attribute scenarios. This reusable knowledge helps you answering questions like what sources to consider for a specific quality of, or what kind of measures should be considered. And the tables will get you started with the elicitation of quality requirements. The quality attribute scenarios in the previous example is about performance, and in this slide you see the table that has been used in order to generate such example. For performance quality attribute scenarios, we have two possible types of sources, internal and external. How do we choose? For instance, if we are defining constraints about how the subparts of the systems are communicating with each other, we are considering an internal source. In this case, we are interested in performance constraints about the entire system, and therefore we are considering an external source, which in our case is a user, but it might be, for instance, the interaction with a third-party system or an external sensor or an actuator, and so on and so forth. Now that we have fixed the source, we have a list of possible stimuli that we can consider for our scenario. Of course, since our source is a user, the only applicable one in this case is the stochastic events that are generated by a user, like in our case, the request to initiate a transaction. So performance is a runtime quality, and therefore the artifact is the system as a whole, or system services, its parts. In this case is the whole system. And when it comes to the circumstances for this scenario, we have a choice between two options. The scenario might be specifying how the system has to behave in normal mode or in case of overload, and in this case we decided that we want to specify a scenario for the normal mode. For the response, we have two options. Either the system has to process the stimulus or it has to change the level of service. For instance, switching from normal mode to degraded mode. The response measure part in the table is quite useful because it gives you a precise characterization of the sub-concerns that are important for performance. Performance issues might be related, for instance, to latency, which is the response time, or throughput, which is the number of service requests per unit of time, and so on. In this case, we are focusing on latency, and we are setting a measurable constraint of 2 seconds. Of course, this is just one example, but you can use this table to explore different options or different combinations of the options that are mentioned in the table, and therefore generate different alternative scenarios. And keep in mind that there is a specific table like this one for each of the qualities. Let's do a small exercise. Let's consider a critical server in a system, and this server is monitored by a heartbeat monitor. The monitor checks whether the server is still up and running. In this slide, we have a quality attribute scenario about availability. The scenario says that whenever a server crash happens, it has to be detected within half a second, and an operator must be informed. Your task is to understand how the availability table has been used to create the quality scenario in this slide. In this and the following slides, select an alternative for each of the 6 parts of the scenario. At this point in the course, you should be able to appreciate that the success of a software project is highly related to creating a design that satisfies the important quality requirements, and that quality requirements are strongly influencing the shape of an architecture. We also have covered quality attribute scenarios, which are a tool to elicit and document quality requirements in a structured way. This concludes the lecture on quality requirements. Thank you for watching.